Hello! Today we're talking about exponents and multiplication. The next couple of notes that we're going to talk about deal with laws of exponents or powers. So just to go over some, some review here, that if you have 7 to the third, the 3 is called your exponent. Sorry for squeezing that in. Or sometimes it might be referred to the word power. So this might be said as 7 to the third power or 7 to the exponent of 3. The 7, is going to be called your base. Now I'm just going over that vocabulary because if we look at it, it says multiplying powers with the same base. To multiply powers with the same base, you add the exponents. So what we're kind of learning today is a little bit of a shortcut for why we're going to do what we're doing. So they're showing us with arithmetic, which means actual numbers, and algebra, which means showing math statements with letters. So if you have 7 to the second power times 7 to the third, that is equivalent to 7 to the second plus the little 3, the exponent of 3, to give us 7 to the fifth. Because to show you, to prove this, 7 to the second in extended form is 7 times 7, and 7 to the third is 7 times 7 times 7. So in extended form, that's 5 7s being multiplied, which is the same thing as 7 to the fifth. So if you have the same base, which in this case you have a 7 and a 7, so the bases are the same, all you need to do is add the exponents to simplify the question. When they're showing us algebraically here, they are saying that a to the m times a to the n, both of those bases are the same. All you need to do is add the m and the n, add the exponents. Notice they're saying where a is not 0 and m and n are integers. If the base is 0, that's a different story. Excuse me. So, question number 1, and A, B, and C, your questions are eventually not going to be broken down like this for you. So this is a little bit easier when they have the boxes because they're giving you a reminder what you need to do. So just know that they will get a little bit more complicated than this. So what they're showing you here is that since these are the same bases, since the 5 and the 5 are the same, then to simplify this, all we need to do is take the 2 and the 8, add them together to get 5 to the 10th. You do not need to actually tell me what 5 to the 10th is, okay? That would be a very large number. All we need to worry about is just that we're simplifying this. For B, this time they're using an x to show us the base, and again, since the base is the same, all we need to do is add the exponents of 3, 5, and 10. So 3 plus 5 plus 10 will give us x to the 18th. For the next one, even though we have the bases that the m and the m, they are the same, it does not matter that the coefficients are different. The only thing that you have to do with the coefficients, which is different than what you have to do with the exponents, is you notice that they're having you multiply the 2 and the 5 together. So you have to be careful here because it shows multiplication, but that doesn't mean all the numbers that you see are being multiplied together. So the coefficient of the 2 and the 5 are being brought out to the front to be multiplied together. Then we've got m to the 10th and m to the 2nd, so we're going to add those together to get 10m to the 12th. So I'm going to ask that you guys go on and try number 2. Okay, so here we are. I have said that I'm taking my coefficients of 3 times 5 and my exponents of 4 plus 7 and simplifying that down to 15y to the 11th power. Question 3 says, does x to the 8th times x to the 7th, or 2nd, have the same value as x to the 5th times x to the 5th? Be careful, you're not multiplying those exponents, you are only adding them together. So x to the 8th plus the 2nd is going to give me x to the 10th, and x to the 5th times x to the 5th, since both of those exponents are the same, then I would just add my exponents together to get x to the 10th. So are they the same? Yes. Okay, now here is another law that we have, which states that when you have a power to a power, this time you will multiply the exponents. So you need to be careful because this is very slightly different than two bases and an exponent being multiplied together. In this case, you are taking 5 to the second and you are making 3 groups of 5 to the second. So if you had 5 to the second, it's like you're really taking that 2 to the third and you end up multiplying those two together. So you end up with 5 to the sixth. So you can put the little shortcut here if you just want to show the multiplication there. Algebraically, notice here we have only one base, and then we have the 2 exponents. It's raising a power to a power, so this time we do multiply the exponents. So I think I'm just going to let you guys do number 4 on your own. Okay, so again, they've broken this down for you so that you don't have to remember if you're supposed to add or multiply. You will have to have these laws memorized, so just be careful here that when you have a power directly next to a power like this, you are going to be multiplying these. So it is good to put that little difference there right now. Check your answers. Back on the top here, I was just trying to show you that if you have 3 groups of 5 to the second, because my base is the same, I am not multiplying the 5, and the 5. The base remains the same. I only have to add the exponents. So I would be doing the 2 plus 2 plus 2, and that's where I get the 5 to the 6th. Number 5, this one has a power raised to the power. So again, you are going to do 9 times 6, so this will be g to the 54th. The last rule that we have is the power of a product. And it says to find the power of a product, raise each factor to the power. So what this is saying, because I know that sentence is kind of sparse, is that if you have 2 times 3 in parentheses, and then a 3 on the outside, an exponent of a 3, that means that I need to raise everything inside the parentheses to the power of 3. So that's why it's equivalent to 2 to the third times 3 to the third. I then cannot apply laws of exponents here, because this is multiplication between unlike bases. I can't combine this any further. The only way I could actually combine it is if I was to do 2 to the third and 3 to the third and then multiply those 2 answers. So for number 6, it says 3 and then CD, everything being raised to the second power. So I'm going to rewrite this out as 3 to the second times C to the second times D to the second. Now, it's not necessary to show the multiplication, but I'm just showing that here. 3 to the second I can simplify as 9, so I'm going to rewrite that as 9. C to the second stays the same, and D to the second stays the same. I'll do one more with you, and then I'll let you practice C. So on this one, again, they're asking us to do everything raised to the third power. So this one's a little bit different because I actually have an exponent on some of the variables on the inside of the parentheses. So this is 5 to the third. Then this is 5 to the second being raised to the third power again. So I need to do 5 to the m to the second times the 3. Then times n to the third times the 3. I'm applying another law of exponent right now. So 5 to the third will give me 125. This will give me m to the 6th and n to the 9th. Go ahead and give C a try. Okay, and that's what I got for my final answer. Please be careful. If you aren't sure how to get 2 to the 4th, you can use your calculator, which you can put in this one I would go 2 and then y to the x, 4, and that gives me my answer of 16. Or if you have one of these calculators, you could go 2 caret, let's turn it on first, that usually helps. 2 to the 4th can also give you 16. Now, when it's just a whole number as a base being raised to an exponent, you can use your calculator, but you need to be careful because when it comes to a variable being raised to an exponent, you won't be able to rely on your calculator. Remember, if you guys have any questions along the way, you need to make sure that you ask me. Have a great night. We'll see you tomorrow.